All right, what's up, fourth period? About to knock this video out and then watch a little football. As you can see, I got a haircut action. I went real short. I love when I have short hair. You can just roll out of bed. Don't have to worry about having that bedhead look. Excited for this week. We got our first quiz. That's a full-on quiz. And we're still going to be graphing. And so this video is going to be a short one. But what I'm going to do is I'm going to pick 3 graphs. I'm going to refresh how we graph with our shifts and our reflections. But then I'm going to really talk about these words off to the side. Domain and range, x and y intercepts, and then talk about asymptotes a little bit more. Just to make you better paint a bigger picture of key features on graphs. Anytime we're talking graphing, any of these words can come up, and we'll see them a lot this semester. So not only will this help you for the quiz, but it'll improve your vocab to help you for later this unit. Okay, so here we go. You're looking for a couple things that you learn that are new, and then any questions you still have at the end, that's what you'll submit in your message to me out on campus. So let's start with one. Let's start with this one. I'm going to pick one that would be like exactly off the quiz to start. I think a great one to do would be, let's do this. Let's do this. I honestly think that would be a great one to graph. Okay, so we know that this parent graph is the square root of x, which is the kind of shooting star graph. I see that there's a reflection over the x-axis. I see that there is a shift. +2 means left 2. And I see that there is a shift down 3. Highly recommend you start there. Kind of getting the feel for your shifts, right? So if a normal parent graph looks like normal square root graph, starts at 0, 0 and then takes off. This one is reflected over the x, so it's going to go that way. And then it's being moved left 2, which is right here, down 3, which would be right there. Okay, notice, notice my x and y axis. Like here's 1, here's 2, here's 3, here's 4. Sometimes you got to be careful the way the graphs are looking. You don't just count the tick marks, you got to read the numbers. So this would be left 2, down 3, flipped over the x-axis. Okay, so that's the correct graph. So then I ask you about domain. This word's used a lot, domain and range. I don't know if students often really understand what it is. When you're looking at a graph, domain is all of the x values that your graph doesn't have to go through them, but that your graph has a y value that goes with it. So for example, the x value of 2, like this point right here at the bottom of our screen, is like 2 comma negative 5. Okay, so there's an x value that works. You plug in 2 into that function and it works. Gets you a y value. Notice that like this is where our graph starts. There are no points to the left of this. There are no points to the left of that value. So the farthest left that our x value goes is negative 2. Negative 3 doesn't work, negative 4 doesn't work, negative 5 doesn't work. Okay, so you always write domain from highest or from lowest comma highest. So the lowest value that we can go is negative 2. We can't go any lower than that. Negative 2 is the last one. And since this is a filled in circle, like a closed dot, we have to use this symbol to show, come on, erase. We have to use this symbol to show that negative 2 can be used. So we can include negative 2. And then this graph goes forever to the right. That's what this arrow means. It literally goes forever. So every single x value that's greater than that, 2, 3, 4, 5, 6, 7, all the way to infinity, all of those work. So our lowest value, our minimum x value that this function has is -2, but the maximum has no bounds, so it goes forever. So the domain of our graph, the kind of, you just show in what's called interval notation, the lowest to the highest, our domain goes from -2 to infinity. Okay. The range, domain is x, range is y. So we're looking for y values now. So you still do low to high. So we'll do low, comma, high. So y-axis is up and down. Now we're looking at this. We're looking y-axis. I think that this point right here, the big dot that we're emphasizing, it's right there at 3. That's as high as it goes. This graph will never go above 3. So that's actually our maximum of 3. The highest point is 3. And then the fact that this arrow goes, it goes down forever. Even though it looks like it's starting to be flat, it actually will keep going at a slow rate forever. So the minimum y value, there is no minimum y value. Okay, it goes from -infinity, like down here, all the way up to 3, stops at 3. Never goes above this big kind of line that I'm just scribbling on. The graph never goes above that. Okay? So that's the domain and the range. X-intercepts is just where does your graph, I'll use the highlighter, does our graph ever hit this line? Does it ever hit the x-axis? The answer is no, it does not. Y-intercepts is does our graph ever hit this line? Yes, it does. Okay, it does. I'm not going to be super specific on exactly where it's going to cross at this point. Let's just say yes, it does have a y-intercept. It's right here. Okay, but since we're just sketching the graphs, let's just stick with yes or no. We'll talk more about those intercepts later. And then asymptotes. Does this have like an invisible boundary that we can't cross? Any asymptote equation? No, it does not. Okay, let's do a couple more. Pause this video if you want to go back and watch, because I'm about to erase this. But that's the basics of domain, range, intercepts, and asymptotes. Let's do one that does have an asymptote here. Nice. All right. Let's graph this one. Y equals, let's do a double reflection. Negative natural log of -x, but we're going to shift it up to. Okay? So what do we got going here? We need to graph the parent graph. If you don't have these memorized yet, you're in trouble because you're going to be in a tough spot, okay? You've got to go memorize those top 10 parent graphs. A natural log graph, which is this, ln of x, that goes through the point 0, 1, or 1, 0, excuse me. It has a vertical asymptote down the y-axis, and it looks like this. That is the basic graph. But notice we are reflecting it over the x-axis and the y-axis, and then we're shifting it up too. So we always do reflections first. So we're going to pretend like we're going to reflect this like it's a mirror right over the x-axis first. So how would I reflect that over the x-axis? That means what's down here, this section, would be reflected over, like folded over, and it would be up here. And then this portion that's up here gets reflected over and would look like that. Let me show you again. It's just, You can do it in pieces like me, or you can just look at it and you're like, okay, imagine if we just took that and we just flipped it over, rotated it over the x-axis. This would be down here now. This will be up here now. So it would look like that. Point didn't move. Point didn't move. That takes care of this. We'll put a little blue check mark right there. Now we need to reflect it over the y-axis. This one's a little easier to see. Just imagine if we took where that graph is and we folded it over the y-axis, which I just highlighted. Okay, that would be the point. The point moves too. Point moves to here. It gets folded over as well. And then so it would look like this. So there we are. Let's use another blue check mark. Now we got to shift everything up too. 1, 2. Notice I didn't just go 2 tick marks because it's 1, 2. All right. And there it is. There's our graph. Final answer. So let's answer the questions. Do we see any x-intercepts? Does it ever cross the x-axis? It will eventually, because if it were to keep going, it would somewhere over there. So we'll just put yes. Y-intercepts, no. Because look, there's this dotted line right here, that invisible barrier right on the y-axis, so it's not going to touch that. Asymptotes, yes. And if I even wanted to give you the equation of that line, it's right through the y-axis, so that's the line x equals 0. It's the equation for it. But as for domain and range, domain, we're thinking what x values does this graph, like how does it kind of span horizontally? Well, this arrow right here, big arrow, tells us it goes forever left. So since domain is you do minimum to maximum, it goes forever to the left. So there is no minimum. So it goes from negative infinity all the way to, look, it will never be over here. That boundary cuts it off. So the domain is only half the graph. It's negative infinity all the way up to 0. And it will never go past 0. Like, let me use the highlighter. It'll go forever, 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 forever. Stop. It will never cross that line. So the domain, the x values that can work for this function, stop at 0. Okay? And then lastly, the range. Lowest to highest. Now we're going up and down. Remember, domain deals with x, left and right, and range deals with y, up and down. Well, this has the arrow up. It goes up forever, so it has no maximum. But it looks like it's going to have a minimum. It's kind of leveling off. So we're not exact. Let's just estimate and say that it levels off right at this line. Say it levels off at 0. Okay, I'm just trying to use these graphs to teach you some vocabulary words. We'll be able to be more specific later. But just remember, domain, how far does your graph span horizontally? Range, how far does it span vertically? You always put the minimum number first and then the maximum number second for both of these. X-intercepts, where does it cross the x-axis? Y-intercept, where does it cross the y-axis? Okay. Hopefully that is helpful. When we get to class tomorrow, we're going to keep practicing these transformations. What you got to do is you've got to know right away. You've got to be able to graph that. You've got to be able to graph this. You've got to be able to graph that. You've got to be able to graph 1 over x. You've got to be able to graph natural log of x. You've got to be able to graph x squared. Like, you need to go practice those if you don't know them yet, because we're moving on with or without you. Let me know if you want extra practice. We can just pull out the dry erase boards and get after it. Okay. Send me that message. 2 things you learned, 1 question you still have. Looking forward to connecting tomorrow.